So let us start. uh, Open the book NCRT. So start inverse trigonometric functions.
We already started.
So like what we did earlier was we discussed the domain and range of trigonometric functions, right? And we said that they of these trigonometric functions there are six functions. One of them is like biject. We need to make them bijective so that we can obtain their inverse. For example, y is equals to sine x. So I told you that this function is not bijective because we draw the graph. The graph of sine x, the x value, this is the y value. So we are getting one different values of x. So for example, for 90 degrees is 1, alright. And what is this? 70. Okay, to 70 degrees is again 1. So it is not bijective function because what happens is it is not 1 1, right? Want to map it, for example, which is the x y value. Y value is either 1, let's say 1, we are talking about 1. There are other y values as well, but you can see here for different values of x, 1 is being mapped like this. This type of function is not 1 1 where for different values of x we have same value for y. So what to do to make each one of these functions as bijective? That we'll study. So first of all, what we do when we find the inverse, because there is a function y is equals to fx, then x is what? F inverse y. F is from x to y. F inverse the function from y to x. Alright, the mapping is inverse. What happens is that when you find the inverse, so here domain is what? Domain is x, range is y. Now here it everything become first. So here domain is y because the function is been mapped from y to x. Domain is y and the range becomes x. This is the basic concept that we know already about inverse. So let us talk about the sine function first. Okay. So if we draw the graph of the sine function, let us copy that and paste that PRT of sine x. Voice is too low to be heard. Yeah, why do you speak so low? This is the graph of sine x. When you want to find the inverse of it, so there is another method to find inverse. to find inverse from the graph itself. Okay. No, I am not muted. Can you hear me? I cannot hear you. That I'm saying already. Your voice is too low. I don't know. I don't know. I'm speaking. Oh, okay, okay. Uh, now can you speak? Yeah. Yeah, now it's okay. Okay, all right. So to find the inverse from the graph, what we do is uh, we no, we don't rotate. We mirror the graph by the line y is equals to x. Okay. So what is the line y is equals to x? This is x, this is y, right? The line y is equals to x is a line at an angle of 45 degree to the x-axis. This is the line y is equals to x. So if we mirror any graph with respect to this line, then we get the inverse of the function in the form of the graph. Okay. So if we need to find the inverse of this function, let us see what we will get. So we get something like this. Let me copy it. This is what you will get. Okay. So this one, this is the graph of, let me change the color. This one is the graph for the sine x. Okay. Yeah. This one is the graph for sine x. And when you mirror it with respect to this line, so you get an overlapping image like this. So for the part in the positive x-axis, right, this is the part of the sine x positive x-axis, you get the mirror image, this one, with respect to this line. Okay. And for this part of the graph of sine x, corresponding mirror image with respect to the line y is equals to x is this. Okay, can you understand now? So so in a nutshell, this is the graph of the sine inverse x function. Okay. So y is equal to sine inverse x, because since y is equal to sine x. Now this function in itself is not a bijective. Okay. Why so? Because it is yeah, it is not the inverse this function. This is not even a function. You know why? For a relation to be a function. Okay. So for a relation to be a function, what should not happen is, like, if there is a situation like for each value of x, okay, if for each value of x there can be more than one value of y, isn't it? This is what the definition of a function is. For a value of x, like, because since function is what, function is a generator, so this is a function. You put in something, you get an output. Okay. So y is equals to sine x is a function, right? And if you put in x here, you give the input x, you get an output y, which is sine of x. It processes it. So this function, this is the box of sine x function. If you put in x here, you get sine x, which is the output y. So function is something where for a value of x, suppose x is 1, you should only get a unique value of y for each x. If for each value of x you are getting resembling values, then that would not be a function. For 1, if you are getting y as 2 and 3 and 4 as well, that's not a function, that is just a relation. Okay, you should already know this by now, right? Isn't it? So for each value of x, there cannot be more than one value of y. But here if you see, like if you take this value of x, which is, I don't know, maybe whatever, right? This is some value of x, you are getting the same value of y at this point and here as well, right? So minus 3 pi by 2 and what else? It's pi by 2
minus 5
and pi by 5 pi by 2, right? So for a value of x as 1, right, what you are getting as an output is, so you are getting value of, if y as pi by 2, 5 pi by 2, this is, in this case this is sine inverse x. Okay, this is the sine inverse x function, right? So see here, for x is equal to 1, we are getting different values of y. This is also called as vertical line test. I don't know why I have to say that here, but you should know it. So if there is a graph of function, right, and you need to check whether it is a function or not, so what you do is,
so it's in
you draw a vertical line. Suppose you are given this function, okay, right? So to test if it is a function or not, what we do is we draw a vertical line at different points. And what a function should do is, it should, this vertical line should cut this function only at one point. This is the what called vertical line test. Okay, but if it is not a function, then this test will fail. For example, if this is a function, this is the graph, this is not a function, this is some graph given to you, you need to find whether it is a function or not. Okay, so you draw vertical lines. Now you can easily see that this vertical line is cutting the graph at various points. Yeah, this is just a relation. Okay, because for some value of x you are getting several values of y, isn't it? This is, in other words, it's called a vertical line test. So that's what we are discussing here, that if you just take the inverse of sine function, you get a graph like this, which is not a function. Okay, so in order to make this a function, because we are studying, the chapter name is inverse trigonometric functions, so in order to make these inverse functions, what we do is we will restrict, okay, we will restrict the domain and range of these functions so that they may become
bijective.
Yeah, so what you should do is, if you see in the book, let me draw this, I will copy paste instead. Final result is something like this. So yeah, this
Yeah.
this you can see
Yep.
what he has done is book it is written that for the sine function, okay, so
Yeah.
if sine function, so if we restrict the domain to minus pi by 2 to pi by 2,
Yeah.
see the x value is translating in the form of angle because this is the inverse function, okay.
Yeah.
In the original sine function we have pi by 2 minus pi by 2 on the x-axis and the
Yeah.
values 1 and minus 1 on the y-axis, but in the inverse you will get these values in the opposite, okay, and the
Yeah.
x-axis values are 1 and minus 1 like this. So
Yeah.
if we restrict the domain of original sine function, so original sine function is this is the original sine function, so minus pi by 2
Yeah.
is this one,
Yeah.
plus pi by 2 is this one, okay.
Yeah.
Now if you take the inverse of this restricted function only, which is from minus pi by 2 to pi by 2, all right, how will you
Yeah.
take? You will just take the mirror image with respect to y is equals to x, right?
Yeah.
So you will get something like this,
In the
this,
graph.
yeah, this much only. You will not get all of these things when you restrict the sine function from minus
Yeah.
pi by 2,
You only get
okay. So because you will only get from minus pi by 2 to pi by 2 only.
pi by 2.
So this function now, which is y is equals to sine inverse x, you can easily verify that this is now a function, because for each value of x you will get a unique value for y, you will not get multiple values for
Okay.
y, okay. So this is how we make original trigonometric functions restricted and then we
Okay.
find their inverses, okay. So what we did was, see, y is equals to sine x, its domain and range we should write. What is the domain of sine x? Y is equals to sine x,
All real number.
yeah, very good. And what is the range? This is the domain, this is the range, from minus 1 to 1 including both. Now if we restrict the domains minus pi by 2 to pi by 2 with both of them included, okay, we still get the same range because 1 and minus 1 are already included in this, right? See here, you will also get 1 at this point, you will also get minus 1 at
Minus
this
1.
point from minus pi by 2 to pi, so there is no harm in, there is no change in the range, right? But you have restricted the domain, so this restricted function will give you an inverse which is a function. That's just the point, okay.
Yeah.
Now the branch with these restricted range minus pi by 2 to pi by 2 is called the principal value branch, okay.
Okay.
So what will happen is, so this is y is equals to sine x restricted, right?
Yeah.
And you know what will be the range and domain when we make it inverse? I told you that domain and range,
It would be opposite. Like
yeah,
minus 1. I
okay,
mean the domains.
they are interchanged. So this is the function, inverse function that you will get finally, okay. This is the
Yeah.
final. So for this inverse function the domain is minus 1 to 1 and the range is minus pi by 2 to
Minus
pi
1 by
by
2.
2. Now this range
Yeah.
is called the principal value branch, okay. This is called the principal value branch. Anything between minus pi by 2 to pi by 2 with respect to this function sine inverse x will be called as principal value branch. Okay.
Yeah.
You could have asked one question here. You could have asked why we should restrict this from minus pi by 2 to pi by 2, right? Only because we could have restricted it
Maybe.
from 0 to pi as well, or 0 to 2 pi, sorry, isn't it?
Won't that be like, I don't know. I don't know. Like,
See, there is no harm in taking a range, okay, which would make it.
but maybe
It is just it is just the convention. We could have chose the range of this sine function according to like whatever we want, provided that this inverse becomes a function. Okay, that's according to what we want. But this is just the principle in books that is followed. Okay, in fact you could have chosen like minus 3 pi by 2 to pi by 2 as the restricted interval. Okay, I mean that should cover the whole range 2 pi, that is obvious, isn't it? This will cover the whole 2 pi, isn't it? You subtract minus 3 pi by 2 to pi by 2, you will get 2 pi.
yeah.
Similarly, if you subtract minus pi by 2 and pi by 2, you will get 2 pi. So that 2 pi is a constant, right?
Yeah.
But you can take any of the intervals, it does not matter. But generally what we do is we follow the book's principle. That is why he called it as a principal value branch. Okay, and we should assume it as such. We should not do whatever we want. We will assume that from now onwards we will restrict the sign from pi by 2 minus pi by 2 to pi by 2, so that the inverse is this, and this will be called as the principal value branch. We will not amend it according to the requirements. We will just assume that this be the inverse. Okay, that is just the explanation to the question you had any. Now in the similar way, we will do restriction of the remaining functions. Okay, and let us see the for the cosine function. So have you got this one? Let us now the cosine function. So second, the first one, the first y is equals to sine x. Second one is y is equals to cos x. First of all, I will copy the original graph. This is the graph of y is equals to cos, correct? Now the same principle is getting followed, replicated here. If you don't do anything and just take the inverse of this by taking the mirror image with respect to y is equals to x line, then you will get something like this again. Okay, which will again not be a function because that would fail the vertical line test. Make it a function again, we will restrict the domain of this. Okay, so if we write the function itself, domain and range, the original one is the domain and range, it is real. And what is the range? Same thing, isn't it? So if we restrict it, from where we should restrict it? We restrict it from minus pi by 2 to plus. Where is minus pi by 2? This is minus pi by 2, right? And where is plus pi by 2? This is plus pi by 2, right? Mm, okay, so would that be counted as a inverse, valid inverse? Do that. What will happen if we take the inverse of this? This is the right, and if the line is this, what we would get? Let me first draw it. See the answer. Just a second. So if you take from minus pi by 2, where is minus pi by 2 here? This one, right?
Yeah.
Plus pi by 2, this one, you will get this. Now there is a problem here. When you are taking from minus pi by 2 plus pi by 2, our issue is not resolved because that would also fail the vertical line test. So that's why we don't take the same restricted domain as that of a sine function. What we will do instead is we will take this as the range, 0 to pi. Okay, so yeah, you will take 0 to pi, we will restrict it from 0 to pi. So from 0 to pi, this, right? This, if you take the replica, like, sorry, the mirror image, so this is what we will get, 0 to pi, right? Now the range is 1 1, and if you make it an inverse, you will get 1 minus 1 to 1, 0 to pi. If you take 0 to pi, there is no confusion, no here, right? Okay, this is the function now, correct? So like, it depends, you cannot just say that if sine is restricted from minus pi by 2 to pi by 2, the same thing for cosine. You will have to see whether that accounts for a valid thing or not, right? Are you getting it? Similarly, you see, I should not be drawing this, I think. So for the tan function, okay, so let us see for the cosine, because cosine, sorry, the cosec is the inverse of sine function. Okay, I have to, I think, discuss it, because otherwise you will not be able to follow. This is the cosine x. Sorry, cosec, I am saying cosine again and again. Cosec x is equals to 1 by sine x. What is the domain and range of this? What is the domain of cosec function? All real numbers, except and pi. So real number, all x lying in R, and x should not be equal to pi. This is how we should write it. Okay, what is the range? See, range will be real number minus from minus 1 to 1. Okay, everything that was covered in the sine will not be there in the cosine. That is what it is, real number minus 1 to 1. Okay, now we want to find the inverse of this. So first, if we see the graph of cosec, what is the graph of cosec? Do you have you even on that? Or let me copy it to you. I don't think you have seen that graph.
Means then the yeah.
It's like this. This is the graph of cosecants.
Uh,
Do you wonder why is it so?
because,
Inverse of sine, okay?
yeah.
This is inversed, this flap is inversed, and everything else, right?
Yeah.
Now, if you want to make it an inverse, what you will have to do? You'll have to restrict it, right? So in this case, what we will do? We will do. You see the book now? It's in the book, right? In figure, I think I should. This is the inverse function. This is the original function. Okay. So for the function y is equal to sec cos x, right? So we will do real number minus 1 to 1, okay? Range will be the domain of this,
Yeah.
but this one will be restricted to some amount. What is that amount? It is minus pi by 2 to pi by 2, the same thing that is for sine, right? Except that you cannot include
Zero.
a 0 here. All right. Why this is case? Can you guess why it is so?
I don't know.
See, if you see y is equals to cosec x is equal to 1 by sine x, if you substitute in x is equal to 0, which is sine 0 is 0, and that would be 1 by 0, so cosec x would be undefined.
Right.
It would be undefined for 0. That's why we have to exclude that, okay? So this is the case for cosec. Now what should be the case for sec? Can you guess it on your own? Rather directly tell me the, can you tell me the domain and range for
Or
sec?
sec.
Uh,
Uh,
see, uh,
Focus.
this would be here copied, isn't it? Because the cosec,
Oh yeah.
all right. And what would be the range? It would be 0 to pi, except what? Should be exception. There should be some exception here, I think so. Where cos function is 0, remember, okay? Y is equal to sec x is equal to 1 by cos x, okay? Now if cos is, sorry, x is 90 degrees or pi by 2, okay, then cos 90 is 0, 1 by 0 is undefined, sec x will be undefined for x is equal to pi by 2. That's why you will have to exclude pi by 2. You getting it? What I've done, and the same thing that I did for the cosec function.
No, I got.
If I do it all together,
No, why is okay?
Tell me, you can ask.
Like what?
Why you speak so?
Like here, is this
Yeah,
fine?
yeah. It's
No, can you just repeat what you said?
I'll have to like the initial? This sec function only, or the
Only the sec function.
y is equals to sec x? What is the domain of sec x function? Tell me. Is the domain
Of.
sec x, just the
Oh,
sec
okay. Uh,
x belonging to R, but x should not be equal to 1 pi by 2. What is the range? It would be the range of cos x
yeah,
minus
R.
real number, isn't it?
Yeah.
R minus 1 to 1, isn't it? Now when you find inverse, you have to exchange, right? This would be here, but then
Sure.
what you would have done is, when you took inverse, you should have to first restrict it, because that would divide from being an inverse. So when you restrict it, what you get? You get 0 to pi except pi by 2. Should I draw the graph also? Let me draw. I think you have not understood. Have you got this for Cosec?
I got it.
Then why not getting it for Cosec? The same thing, no? This is the sec function on the left hand side, and this is the inverse. Okay. Now, if you see, the domain of this sec function is real numbers, except that x should not be equal to 2n plus 1 pi by 2. Why so? Because it would become undefined for pi by 2 and its multiples, right? And the range is real number minus 1 to 1. You can see clearly here that this function is not taking any value from 1 to minus 1. Okay, this is a whole here. Okay, from minus 1 to 1, there is no function of cos x, sorry, sec x. Now if you want to find it inverse, what you will do first, you will have to restrict it. So first we found the inverse without restriction, and then we will test it for vertical line. Okay, right? So if you had taken this as the range, this would fail vertical line test. If you had taken this as the range, it would fail the vertical line test. So you cannot take this whole or this whole as the range for sec inverse x. Okay, what we do is that instead of this whole, we take half from this, half from this. Okay, are you getting it? So see, the domain is real number except minus 1 to 1. So the domain, so from 1 to 1, minus 1 to 1, this is not taking any value, right? It is starting from minus 1 or starting from 1, isn't it? Because that's the maximum it is having value. All right, and now what is the range? This is 0 to pi except pi by 2. Okay, this is 0 here, this is pi here. Okay, and you should not take the value pi by 2, because this is the dashed line, right? If you take it as pi by 2, it would become undefined. Tell me what was the confusion that you did not having?
No, I just
Hmm? Should I continue?
yeah.
Okay. Similarly, you can do for next function, tan x, the domain and range. Hmm? It is the set of real numbers, but exception is there, I think. Size in R, except x cannot be equal to what? 1 plus 1 pi by 2 again, because 1090 is infinity, right? And what is the range? It is the real number, isn't it? You can verify it from the graph itself. If you draw the graph of 10x, this is what it looks like. Like this. Second, this is what left side we have 10x. So you cannot take any value which is a multiple of pi by 2, because that would make it undefined, right? So that's why we took x cannot be equal to minus 1 plus 1 pi by 2, and the range is real number. So you can see it can take any value for y, right?
Yeah.
That's why it's the real number. Now when we find it inverse, the inverse would look something like this,
Yeah.
and it would, this as a whole would fail the vertical line test, so we would have to restrict it.
Yes.
So what we did was we restricted it from minus pi by
Minus
2
yeah.
to pi by 2, with both of them not included, right?
Yeah.
Because otherwise it would be undefined, right? So how can we write this? When we
So
make it
the
y is
domain.
equal to tan inverse x, okay, so the range will come here, right? This would be
So
the real number. You can see that the
yeah.
x value for the tan inverse x can be any value, right? What would be this one? This would be copied, except for the restriction, right? What
So
will the restriction be?
minus pi by
Minus pi by 2, minus pi by 2, pi by 2, and bracket opened. All right, so you cannot take those exact values. Okay,
that's for
yeah. Finally, for cortex, can you directly write for the domain for the inverse, domain and range for the, you can see in the book. All right, see, the domain would be the real number again, but the range would be changed 0 to pi. Okay, do I need to verify this? I think this is pretty understood. You can easily find that. Okay,
oh,
so after doing all of these, get a table which looks like, earlier we had drawn the table for normal trigonometric function. This is the domain and
yeah.
range of inverse metric function, right? You should remember it by heart. Learn it.
Okay.
This is called the principal value, principal branch, and we took it as as per our convenience, right? Principal branch that we took was as per the standard, you can say, right? So you should just remember these ones. And now we will should we do a question? Just a sec. Yeah, we should do a question on this. So you should note few things. First thing that is
You
to be
should not see
noted, yeah, not like not note.
no, you
What?
no, you said that.
I cannot hear you, so how will I respond?
Hello.
Yeah,
I think I'll have to buy a new pair of ears. Anyway, I saw you.
I cannot hear. I don't know what are you saying.
Hello.
You speak hello in the loud voice and then again goes down.
Hello.
Yeah.
Nothing.
So first thing is that we should not confuse like sine x inverse the same as sine inverse x. No, this is 1 by sine x. Okay,
That one.
that one is itself a function. Xi is equals to sine inverse. This is a notation to denote inverse trigonometric function, so they are not the same. Okay, so now let us do some questions. Example 1 says that find the principal value
Science.
1 by root 2. Now this is your test. So see here. Earlier we used to do y is equals to sine x. So we put in some x here, like some angle 90 or 180, and we get the value of sine x for that angle, right? Here it's the opposite. Here what you are given is you have put in some value for the function. You have to find the angle for which it is valid for sine. Okay, that is what an inverse is. So we need to find for what angle sine is equal to 1 by root 2. That's what it is, isn't it? So do you remember for what angle it equals 1 by root 2?
Uh,
Hmm?
55.
5. So 0, 1. Yeah. So theta should be pi by 4. But this is not how we do it. So what we do is we first equate it with some value y. Okay, because y is what? Sine inverse x. That's why we equate it to y. And then what we do is, I have already told you this in physics lecture, that if there is a sine inverse here, if it goes there, so what will it become? Sine y will be equal to 1 by root 2. This is the same thing as this,
Oh, yeah.
isn't it? So now this is the same thing. You just it is the just the how you read it. Okay, now it is some value of y. Okay, which should be some angle, isn't it? Because in sine you put in some angle which gives some value to it, sine y, right? You have to find that y. Okay, so how you do it? You just say, either you do it like this way, so sine y to sine pi by 4, you replace this with sine pi by 4, and we do that. And now this is sine, this is sine, so they both cancels out each other. Y is equal to pi by 4. But you don't cut it like this. Okay, this is just a second. Okay, so let's continue.
Okay.
Or at
We
this.
got
In this way you
y.
can find this, right?
Yeah.
But you know one thing, there
No.
are infinite value of y that can give us 1 by root 2.
Okay.
That's why we restricted that thing, because then what value you give to y, isn't it?
Right.
So that's why for sine inverse x, what we did was, see, the domain of sine inverse x is restricted from -1 to 1, and the principal branch is from minus pi by 2 to pi by 2. So whenever you will give answer within this principal branch, you have to give.
Oh, so it should be with it. Okay.
Okay,
Yeah.
that's why we always stick to this principal branch. Otherwise there can be different values for y. See,
Yeah.
if you
Yeah.
draw the
I
graph,
got it.
there would be different values. That's why we stick to this, right?
Yeah.
We should give the answer for y between these values, and
Okay.
that's what.
So, pi by 4 is
Yeah,
does go
pi by
like
4 is
that.
between minus pi by 2, pi by 2.
Yeah.
45 will be somewhere here, isn't it? Pi by 4 is 45, pi by 2 is 90, so it is between minus 90 to 90. Correct?
Yeah.
That is how we do it. The second question is example 2.
Okay.
It says find the principal value for cot inverse, that's minus 1 by root 3. Okay, so if you write it, equation it equal to y, then cot y would be equal to 1 by root 3, and we know that cot is the reciprocal of tan function. So when tan is root 3, the cot function will be 1 by root 3, isn't it?
Yeah. Yeah.
So for
5 by 3.
60-degree, it is root 3 tan, isn't it?
Yeah. So, 5 by 3.
And 60 is root 3. Okay,
Yeah.
then should be equal to what?
It should be
60, right? So
5 by 3.
for I is equal to 5 by 3. Oh, I'm sorry, this is negative.
Oh,
You have to get minus 1 by 3. Okay,
wait. That is not.
so y would be minus 1 by 3.
But so can you not write what y is?
See, we would have written it like cot minus, so what is cot pi by 3? Tell me. Pi by 3 is 1 by root 3. Now if you put in a negative sign here, that would be negative 1 by root 3, right? Can we replace this thing with this?
Yeah.
Minus cot pi by 3, and this is cot, taking cot both sides, but that's a negative sign, you cannot cancel it, isn't it? So there is a catch here. Now you will have to find some means. How do you do that? You will use the trigonometric rules here. Okay. First of all, one thing that you should remember is for cot function, the range, principal value range is from 0 to pi, right? So you should get an answer from 0 to pi, is what it says. Pi, but not including them. So this should be in your mind always. When you practice it, you will understand it. Now you will have to cut it or cancel it. So you should first reduce this negative sign, get eliminated this. How will you eliminate? What is cot 180 minus theta?
Oh.
See, this is all positive.
Caught one minus.
Okay, so 180 minus is in the second quadrant, and in the second quadrant cot is negative, and because since it is 180, so it will remain cot theta but with a negative sign.
Yeah.
So can you replace this? If this is theta, suppose theta is pi by 3, what you, so pi, right? 180 is pi.
Yeah.
So what you will get here, cot pi minus pi by 3. So that means cot 2 pi by 3 is equal to minus cot pi by 3.
Yeah.
Now you can put in the put
Oh,
this.
so x will be pi by 3.
Just a minute, you should write it. Not x, that's why y is equal to 2. This is the answer. And you should check it. This is should be in the range principal from 0 to pi. It is between this range, right? This is how we do this question. Okay. Now let us do some questions from the exercise. Maybe a one. I'll give you rest just 2 minutes because we'll start 6. Uh, okay. Let's do question number 2. Exercise 2.1. Question number 2. Exercise 2.1. Question number 2. It says you have to find the principal value PV cos inverse root 3 by 2. Let's say it is y. So cot y would, is it cot? No, that is cosine. Cosine y is equal to root by 2.
Yeah. And then.
Is it negative 1? No, it is not negative.
So.
Now, if you see what is uh, sine cos 60, cos 30 should be right. Yeah, pi by 6. Cos y is equals to cos pi by 6. I is equals to pi by 6. A very easy question, right?
Yeah.
Why? I am not finding. All of them are easy, right? You can do them on your own, the first exercise. 13th?
Sine.
Where is that? Question number 13. Oh, that's a very easy question. It's just an MCQ. Find the value of if
Yeah.
sine inverse x is equals to y, then which of the following option is correct? Alright, so let us do that. It is given that sine inverse x is equals to y, right?
No.
We need to find the range for y because all of them options they are uh, they are interested in y only, right? We need to find the range of y. How we will find that? See, what is the question? 30 y is equal to sine inverse x.
Yeah.
This is what is the domain and range of sine inverse x? This
Oh,
is
I
just the
think
question from the table itself.
domain is.
Range is minus pi by 2 to pi by 2, and that's y. Range is called what? Y.
Oh,
Domain is x. Yeah,
that's
that's the option
option.
fourth D.
Okay. Yeah.
Because everything is inverse, na? In when y is equals to sine x, this angle is x and value is y. But when y is sine inverse x, this is just become opposite, isn't it? Here x in and y changes because we studied just that only, that is interchange, right? Domain becomes range, range becomes. So I hope you will do this exercise.